The universe is full of mysteries, and addressing them has been one of the earliest inspirations of human beings. A pivotal breakthrough in advancing astronomy and gaining insights into the worlds beyond our planets was the invention of the telescope. Conventional telescopes equipped with lenses are limited to capturing the light within the visible spectrum only. These telescopes can primarily gather light from nearby planets and galaxies, and not very far away objects. The reason behind this limitation lies in the continual expansion of the universe. As a consequence of this expansion, light from distant objects undergoes a redshift. This occurs as the increasing distance between us and the object causes the light to stretch, shifting its wavelength beyond the visible spectrum. Specialized telescopes known as radiotelescopes are designed to effectively detect such light, capturing signals outside the optical spectrum. In 1965, two American astronomers, Arno Allen Penzias and Robert Wilson, realized that their radio telescope is detecting signals that appeared as noise. They started to investigate deeper into the noise in order to eliminate it. However, they noticed that this noise has a unique feature. It has the same energy and strength at every direction, regardless of the location or time of day. In fact, if the noise originated from a specific direction, it should have exhibited increased strength when the telescope was pointed toward the source, or it would have shown variations throughout the day due to Earth's rotation. So, shortly after detection, it became a mystery. Where does it actually come from? This accidental discovery occurred at the same time when the theories about the Big Bang and the expanding universe were being developed and discussed. And indeed, only the Big Bang theory could solve this puzzle. This signal is actually the light from the heat and radiation left over from the early universe, the time when the universe started to exist with rapid expansion and when the first atoms formed. This is why the light fills out the entire universe uniformly and is red-shifted to the microwave spectrum. Astronomers gave this light the name cosmic microwave background. If this is the only fossil that we have from the early universe, it would be so valuable to analyze to discover as much information as possible about the history of the universe. Deep inspection of the cosmic microwave background revealed one crucial aspect. It is uniform but not 100%. There are very tiny fluctuations that can be detected by sensitive satellites. But what does the fluctuation say about the formation of the universe? As mentioned earlier, the cosmic microwave background is emitted during the formation of the first simple atoms of hydrogen and helium, filling the entire universe, which was considerably smaller than it is today. The observed fluctuations indicate that the density of these initial materials was not uniform. Certain regions had higher mass than others. Consequently, areas with higher density experienced stronger gravitational forces, which slowed down the expansion. Conversely, regions with lower density expanded more rapidly. As the expansion of the universe continued, denser regions managed to neutralize its force through their strong internal gravity and began collapsing. These collapsing regions eventually gave birth to the first stars, followed by the galaxies that we observe today. This dynamic explains why galaxies are constantly moving away from each other, while within galaxies, the distances between objects remain stable due to the restraining force of gravity. Cosmic microwave background has experienced an amazing journey of being initially regarded as a disturbing noise to becoming an invaluable trace from the early universe. After around 60 years from the detection, there is still lots of research and analysis being carried out on this light to uncover further information about the early universe. We eagerly anticipate what other astonishing results will emerge from this oldest light.